Hi, welcome back to my PM Research number 5 steam engine model build. This is a delivery from Hobby Metals, who sell small bits of metal for hobby metal making, and they're my favorite supplier for this kind of stuff. I only need a few inches of each of these different things, but I'm buying the 1 foot length, so I'll have plenty of stock for future. And initially we just need a little bit of this 3/16 brass. Just checking it there for square. It's within a few thou of where we need to be, and that's where this part goes on the model. It is the valve slide. It's held in place with 2 of these little casting things, which on the cast iron version of this there are 4 needed, the underneath and the top, but we only need to build the top here. So getting a flat surface on the back, initially with file, and then on my surface plate with some wet and dry paper. And then the right hand side of this marking line is measured with a caliper, and the left hand side is my touch off with the 1/4 inch end mill. Using a long 1/4 inch end mill here because the short one will not reach with the vise up at this angle so close in. And now we just take it in 3/32 of an inch down and 3/32 of an inch across in increments, but that's getting kinda close to the vise. We are using the 2 castings on the end that we're not needing as a clamping surface, and then taking it down in increments. But I did decide here that I wanted to set my 0 with a feeler gauge so I didn't cut into the vise or break the end mill on the vise, because I don't have another one of these. So that's just making sure I've got some space. If you're enjoying these videos, please like and subscribe, and please give me your feedback in the comments below. It is useful to learn from people who know what they're doing, and I thank you very much for that. I'm taking it down gradually. Now if I do take this a little bit far, which I think I do because there is a little bit of run out, particularly with this long end mill, I can bring it down to size later by sanding back the back surface again, and that will bring the angle down. And here I've cut those off and done that truing up so we have a nice close sliding fit, and then we're going to hold them in place with super glue. And the real trick here is not to glue your fingers to the steam engine. And by gluing it in place with the shaft in place from the valve slide, it does make sure everything is going to be square and lined up. With that in place, we add some weight to make sure the glue takes, and go away and have some coffee. I'm using the wiggler to find the center of the boss in the, I guess it's the Z-axis of the steam engine, the up and down part. And we're going to be going left and right from center. So we've already centered the mill on the collet block, which should be the center of the engine, and this is all mounted on the mandrel from the original boring of the cylinder. Center drill through for a 256 tap, and then we drill the clearance hole down to the parting line. Now in retrospect, I should have cut the features on the valve shaft before I took this off, but I was thinking I'd be mounting it in the vise and doing V-blocks for that. But turns out the V-blocks I have aren't really going to work for something this small. So what I decided to do is after tapping the holes is to use this as a V-block to mount that part and use the clamping screws to hold it in place. The mistake I made, but I got away with, is not using a nice solid shim material to make these clamps actually clamp, because remember, these are spaced currently for a sliding fit. So I should have put in some Coke can or something like that so that these would actually screw down on it. But here we do get a nice sliding fit, and it slides in and out nicely. Okay, that's enough. You're having a bit too much fun with that. Stop it. So here we go, we've glued up the part and found the center. It turns out I did not really leave a lot of excess on that piece of raw material for this next operation. So I've got it marked up for where I want to countersink and drill for this single hole that goes in here. And here I'm using some 3D printer filament to shim out the part, and as I say, I probably should have used some Coke can and screwed it down tighter. I did get away with it. And we center drill and again tap for 256. The other part we're working on here is the square part of this casting. And this is a new casting I bought as a replacement and started off on the grinder to take off the extra and to flatten up the back, using the side of the grinding wheel to start the flattening, and then onto the wet and dry on the surface plate. Now here I blacked it up with some Sharpie, and I did do another pass there until the Sharpie came off evenly. Now we have fun with drilling. I already had the hole pattern in the CNC code for drilling these from when I drilled the holes on the valve box. But here I'm using my very last tiny center drill to spot these. And when I get round from this rotation, first two holes went good, third hole didn't seem to go very far in, and the rest of them didn't seem to go far in. So I thought maybe there was a bit of resistance there and the drill wasn't tightened enough, so I tightened it up and re-zeroed and went round again. And same thing sort of happened, except I think I broke the end of the drill there. If I didn't break it on that one, I definitely broke it on this one. So there's something wrong with these front two corners. They seem to be reluctant to be drilled, and I think this is a phenomenon you get with cast iron, is sometimes you get inclusions that are extremely hard. You know, there's a lot of carbon in stainless steel, not in stainless steel, in iron. And that's what they make diamond out of as well. I don't think it's really diamond, but it's certainly harder than the drill is. And it's not good. So here I went with a bigger center drill, thinking I'll just spot it with the tip. And maybe that'll go better. And it did seem to work on the right hand hole that's nearest to us here. But it didn't work with the one to our left. Now I'm going around here again with an extra 10th thou depth, thinking I'll make an impact on it, but it's really just not working at all. So I pulled out my 16th inch ball end carbide end mill, and now I've finally got some impact on that close left hand corner. So I add a few thou to the depth and go around again. and now it's really starting to take out some metal. And this is narrower than the hole that I need, so this is good. So now I have them all properly spotted, I go in with the cheap Harbor Freight drill to see if this will go through, because these work okay, and as I say, they're cheap. And I'm running out of drills of this size. I need to buy some more, so I'm using this one, but that doesn't sound good. And yeah, that's the end of that drill. However, I checked my measurements and the end mill is actually long enough to go all the way through. So rather than just using it as a center drill, I'm using it as a pilot to go all the way through. And hopefully that'll let us drill these holes and get them done. And this is my somewhat better drill set, and this is the last drill I have in this size range that I need for the clearance. So I need to go shopping or give up for the day if this one fails. So these holes were already drilled through. This corner is where we had a breakage. I was able to get the end of that other drill out with the pliers. And this is the first virgin hole, as it were. That worked okay, and this is our suspect. And this is kind of dodgy, and we have some fireworks, but it powered on through, and we have a hole. It did turn out that hole was slightly off. I had to elongate it slightly to get the screw in, but it all worked out well in the end. And doing the narration here, the valve slide still needs a hole in the end that I forgot about. That has to be drilled and tapped. Thanks for watching.